Hi everyone, it's Mrs. Jennison here again and welcome to our next lesson on this topic. Today we're going to be looking at group 7, which is also known as the halogens. As with all of our lessons, it would be really useful if you had a pen or pencil and a piece of paper so that you can work through the activities with us as we go through the video. And it would also be really useful if you had a periodic table today as well. Our challenge today is to be able to predict properties from given trends down group 7. Our aspire be able to explain the trending reactivity of group 7. So first, let's familiarise ourselves with group 7. What I'd like you to do is, using a periodic table, I would like you to draw the electron configuration of fluorine and chlorine. You should have something that looks like this. Fluorine has got 9 electrons, 2 in the first shell and 7 in the second, and that is why it's in the second period of the periodic table. Chlorine has got 17 electrons, 2, then 8, then 7. And because they are in group 7, both of these elements have 7 electrons in their outer shell. So, using what we've just drawn, I'd like you to think about what predictions you would be able to make about the group 7 elements. Think back to group 1 and group 0 that we looked at last lesson, and just take a few minutes to think about what properties and predictions you may be able to make. Now, the group 7 elements are called the halogens. Because they are found in group 7, they all have 7 electrons in their outer shell, and because they are on the right-hand side of the periodic table, they are non-metals. Now, on the screen, I am showing you a graph that shows the melting and boiling points of the halogens, the group 7 elements, as you go from fluorine at the top of the group to iodine at the bottom of the group. What I would like you to do is use this and your own knowledge to describe and explain how boiling point and melting point change as you go down the group. And as a little hint, I've just reminded you to think about the size of the molecule. Now, the melting and boiling points of the halogens increase as we go down the group, as you saw on the graph. And that's because the size of the molecule is actually increasing. Now, these elements are diatomic, which means two atoms bond together to make their molecule. And that means that as you go down the group, the size of that molecule is increasing drastically because you are getting more electron shells and bigger nuclei. Now, if we now use the data that we've got to think about the states of these at room temperature, it becomes even more evident that the melting and boiling points are increasing. Because fluorine and chlorine are both gases at room temperature, their boiling point is below room temperature. Bromine would actually be a liquid and iodine would be a solid because both its melting and boiling points are above room temperature. The colour of the substances actually gets darker as well. Fluorine's like a pale yellow gas, chlorine's a pale green gas, bromine's like a brown orangey liquid, and iodine's a black solid that sublimes with purple fumes. It's actually quite beautiful to look at. Now, over the last lessons, we've been talking about how elements react with each other. And we talked about how they all react to get a full outer shell. And that's not different for group 7. They still need to fill that outer shell, and that's why they react. Now, because they have 7 electrons in their outer shell, that means these elements will all gain 1 electron to have a full outer shell. Now, this time, when they gain that electron, they are forming a negative charge because they will have more negative electrons than they have positive protons in the nucleus. So that gives that ion an overall negative charge. Now, at the top of the group, the outer shell is closer to the positive nucleus. It will be easier for fluorine to gain that electron than bromine will, because bromine's outer shell is further from that positive nucleus, which means that fluorine is much more reactive because it's easier for it to gain that electron. Now, it's really important that when we are discussing the halogens and the halide ions, we use the correct terminology. If we are talking about the atom or the molecule, we use their name off the periodic table. So fluorine, chlorine, bromine, iodine. But once they form their ion, their name changes. And their names change to end in "ide", which then implies it is an ion. You find this with other nonmetals as well, such as oxide and sulfide. So if we are talking about the atom or the molecule, we have to make sure that we are using the enes, so fluorine, chlorine, bromine, iodine. If we are talking about these when they have formed their ions, we are using ides, fluoride, chloride, bromide, iodide. People lose a lot of marks on that in exams. So, looking at their reactions with hydrogen, we have further evidence for the fact that fluorine is much more reactive than your chlorine, bromine and iodine, because fluorine reacts instantly with hydrogen. Even if the temperature was minus 200 degrees C, it would still react instantly. Now, chlorine reacts quite slowly if it's in dark. However, if you add light to that reaction, it explodes. If bromine is reacting with hydrogen, you actually need to heat it to around plus 200 degrees C in order for the reaction to even start. Whereas iodine, the least reactive, does not react completely, even if we raise the temperature of that reaction to 500 degrees C. So there is some quite drastic differences in how these elements react with hydrogen. So there's a little example where you can see it exploding. Now, a few summary questions on what we've looked at so far before we move on. How many electrons do group 7 elements have in their outer shell? How do the melting points and boiling points change as you go down the group, and why does that change happen? What happens to their electrons when they react? And how does the reactivity change as you go down the group, and why does that happen? I'll leave you a little bit of time to answer those. So you should have, for number 1, 7. Number 2, their melting and boiling points increase because the size of the molecule increases, or that simply the molecules are bigger. All of these elements will gain 1 electron when they are reacting, and as we go down the group, the reactivity will decrease because the electron they are gaining is further away from that positive nucleus, so it will be less strongly attracted. Now I'm going to show you an experiment on these, and it's a displacement experiment. Now this is one they use quite frequently in exams because it really demonstrates the reactivity quite well. So I'm going to pop in a video of me doing this experiment, and then I'll come back to you after that's finished. It's Mrs. Jennison here again. Today we're going to be doing a displacement reaction, and we're going to be doing displacement using the group 7 halogens and their halide salts. So for this experiment I need a spotting tile. I've got chlorine water, bromine water and iodine solution, and I've also got potassium chloride, potassium bromide and potassium iodide solution, and some pipettes. Also, in terms of safety, I'm going to wear my safety goggles throughout the experiment. I've got my lab coat on, I'm stood up, and I will be tying my hair back as well. And because some of these are quite dangerous, I'm in a very well ventilated room and I've got a fan to remove any fumes. So what I'm going to do is I'm going to set up my spotting tile so that I have columns of the salts and rows of the halogens. And what I will do is I will add a few drops of each salt solution into each of these dimples in the spotting tile, and then I will add a few drops of the halogen to see if there is a colour change. If there is a colour change, that means a displacement reaction has taken place, which means the halogen, which has been added, is more reactive than the one that is in the compound, and they have swapped places. So first I'm going to add a few drops of potassium chloride. Then I'm going to add a few drops of potassium bromide. Notice that I'm putting the lids on every bottle after I've used it because that's just good, safe lab practice. And then a few drops of potassium iodide. So now I've set those up, I'm going to add in a row a few drops of the chlorine water. And remember, I'm looking for a colour change. So obviously chlorine is not going to react with itself, but I'm putting it in just so you can see. Okay, so I've just had a slight colour change there, which means chlorine must be more reactive than bromine. And again, I've had another colour change there. So that means chlorine is more reactive than iodine. So it's swapping places. It's displacing. Next, let's add the bromine water. Now this is slightly pale yellow to begin with, so I'm just looking for it to change any more than its already pale yellow colour. Bromine won't react with itself, so we'll discount that one. And you can see we've got a slightly darker colour here, which means iodine is less reactive than bromine. Bromine's more reactive than iodine. And then I'm just going to add my iodine solution, which is very dark to begin with. So we're looking for it to get any darker than that. Which that's not. They are all staying the same colour, which means iodine is the least reactive of the halogens because none of those were displaced. Chlorine is the most reactive of the halogens as it displaced bromine and it displaced iodine. Let's summarise our findings from that experiment. When we reacted chlorine with potassium bromide and potassium iodide, the chlorine was more reactive, so it displaced the other ions. So when it reacted with potassium bromide, potassium chloride plus bromine was formed, and we saw that as a colour change. When chlorine reacted with potassium iodide, potassium chloride and iodine was formed because the chlorine is more reactive. When bromine was placed with potassium chloride, there was no reaction. This is because bromine is less reactive, so it will not displace the chloride. However, when it was reacted with potassium iodide, it did displace the iodide and formed potassium bromide and iodine. And again, we saw that as a colour change. When iodine was placed with potassium chloride and potassium bromide, there was no reaction for either of those experiments because iodine is not reactive enough to displace chloride or bromide from the compound. Now, the reason this happens, if a metal halide is mixed with a more reactive halogen, the extra electron will be transferred from the less reactive to the more reactive halogen. So in this example, in sodium chloride, if fluorine was placed into that solution, the electron would be transferred from the chloride to the fluorine, and the chloride would lose its charge, form chlorine, and the fluorine would gain a charge and become fluoride because it was more reactive. Now, let's have a go at our first question on this. This is a little bit longer, so we are going to bug this. The first thing we want to look for is our command word, which is explain why. Now, remember, this means that we have to give the reason for something happening. They want us to explain why chlorine is more reactive than bromine, and they've given us some other information. When chlorine reacts with potassium bromide, chlorine displaces the bromine. And there we've got a symbol equation for this as well. They want you to use that to explain why the chlorine is more reactive than bromine. Right, a few extra little questions. These are not long answer ones, so I'm going to read through them really quickly and then give you some time to answer them. How does the boiling points of the halogen change as you go down the group from fluorine to iodine? Then they're going to ask us about sodium bromide, which is produced by reacting sodium with bromine. Sodium bromide is an ionic compound. Chlorine reacts with sodium bromide solution to produce bromine and one other product. They want you to complete that word equation. Then why does chlorine displace bromine from sodium bromide? And then they want you to use your data sheet to help you with this, so a periodic table. They want you to suggest which halogen could react with sodium chloride to produce chlorine. So on the first question, you've got a mark for each of these bullet points. So chlorine is a smaller atom, or you could have had that it has fewer energy shells, or you could have also had that its outer shell is closer to the nucleus. So that's our first marking point. The second marking point, you could have had either chlorine has less shielding, or there is a greater attraction between the nucleus and the outer shell, or the gained electron. The final marking point, therefore chlorine can gain an electron more easily. For our second question, the boiling points increase. It would form sodium chloride. Chlorine is more reactive than bromine, which is why it displaces it, and fluorine would be able to displace chlorine. So that's everything for this video. I will see you in the next one, and that is the last video on this topic, and see you soon.